So I want you to work on parts A through D right now. Part A looks like this. X equals 4, x equals 3. These are called roots. Now, our goal is to create a quadratic, and we're going to create 4 quadratics that are really similar to each other, and by looking at the quadratics, we're going to figure out ways to go backwards, to start from the quadratics and end with the roots. So we need to turn these roots into factors. So I'm going to subtract 4, subtract 3, and I get x minus 4 equals 0, and x minus 3 equals 0. These are called factors. In mathematics, factors are two numbers that you multiply together to create a product, the answer to a multiplication problem. Don't know. So I'm going to take x minus 4, I'm going to multiply that by x minus 3, and when I distribute this, I get x squared minus 3x minus 4x plus 12. And in most cases, you can simplify these. Put those x terms together, and I get x squared minus 7x plus 12. And then in each part, you have to answer a couple questions. The first one being, what is the number in front of the x? 7. That's pretty easy. What is the sign in front of the x? Negative. And each of those is important. And then the next one, what's the constant? The constant is 12. That's a number that doesn't have a variable, a number that never changes. And the sign in front of the constant is a positive. So I'd like you to go through, create quadratics from A through D, and then on the second page, I want you to create quadratics for F and G, and then answer the questions. So skip E and skip H. And we'll do E and H together, and then you'll be able to do your assignment for today. So I'm going to pause this video, let you guys finish those parts. So you should have equations that look like this. Okay. Do you notice any patterns in there? Anything that might be useful? What do you notice between all of those equations? And we're basically using the same numbers, but we're getting 4 different equations in the mix. Okay, so looking at the middle term, so with the middle terms, I'm either looking at a 1 or a 7, positive or negative. Where do those 4 numbers come from? Adding the 4 and the 3. So in this case, negative 4 and negative 3 is negative 7. 4 and negative 3 is positive 1. Negative 4 and 3 is negative 1. And 4 and 3 makes 7. So if the signs are the same, the 4 and the 3 work together to create a bigger number. If the signs are different, then the 4 and 3 kind of fight it out, and you end up with something less than 4 or 3. Okay, what else do you notice? The constant is always 12. Why? But why, I mean, we have 4 different equations. Why do all of the constants have a 12? Because it's 4 times 3. Okay? So 2 of the constants are positive, and 2 of the constants are negative. Why did that happen? Something to do with the signs. So if the constants are negative, if the factors have 2 negatives, or if the factors have 2 positives, then we end up with a positive 12. So in this case, the factors have the same sign, and in this case, they have the same sign, and that's going to create a 12. The negative 12s are products of different signs. And we're going to use all of that information to look at a quadratic and then we'll backtrack and get to the factors, and we'll backtrack again to get to the roots. So look at part E on your paper. On whatever space you have for part E, I want you to draw a horizontal line right through the middle of it. And then about a third of the way over, draw a vertical line. And we're going to come up with rules that fit all four patterns. So there were four patterns between A and D, and we're going to talk about all of them. The first thing we're going to look at is the constant, the last term. So looking back here, if my last term is positive, what do I know about the factors? Same sign. Good. So if the last term is positive, then we have the same sign. Likewise, if the last term is negative, then we have different signs. Does everybody get that? So without even looking at the numbers, if I see a plus here, then it's either minus, minus, or plus, plus. Those are the only two options. If I see a negative here, it's either negative, positive, or positive, negative. Okay? So if I look and the last sign is positive, how do I figure out if they're both positive or if they're both negative? The middle term. So the middle sign. So on our chart, let's divide this in half. And if the middle sign is positive, what does that tell me? So if the last one is positive and the middle one is positive, then they're both positive. And similarly, if the middle sign is negative, then they're both negative. Okay? So let's look at the ones that have a negative constant. So looking at this one and this one. If the last sign is negative, what does the middle sign tell me? Why is this term positive? Right, when the 4 and the 3 fought it out, who's going to win? The 4 is going to win because it's bigger. So the reason that this is a positive one instead of a negative one is because the bigger of the two numbers is positive. So if we go to our chart, if I know that the last sign is negative and the middle sign is positive, then the big term is positive. And then the same works on the other side. If the middle sign is negative, then the bigger of the two is negative. When they fight it out, the big number will always win. Okay? Well, let's look at a couple examples. So find some blank space. I think the very last page of your worksheet is blank. Let's look at this. So I want to create factors, and then I want to create roots. So I'm asking, where does this quadratic touch the x-axis? We could just graph it and find the answers, but sometimes we want the factors and not the roots, and sometimes it's way faster to just work it out than it is to graph it. So I know it's an x squared equation, so I have an x here and an x here. What do I know about the signs? So I look, last sign positive, I go to my chart, last sign positive right here. Middle sign is negative, so it must be x minus and x minus. Does anybody not understand that? Now, this is something that will never go away. You will be factoring quadratics for the remainder of your math experience, no matter what you take. You'll have to factor quadratics at some point. Okay, so now we have to figure out where this 40 came from. And we talked earlier that when you multiply the factors together, you get 40. When you add the factors together, you get 14. So we're just going to go backwards. Let's look at the factors of 40. And I highly recommend you write them all down and you write them in order so you don't miss any. So the factor pairs would be 1 times 40, 2 times 20, 3 doesn't work, so we ignore it, 4 times 10, 5 times 8, 6 doesn't work, 7 doesn't work, and 8 is already listed, so we don't need to list it again. Okay? And what do I know about the signs? This group is negative, and this group is also negative. So if they're both negative, can I use any of these pairs to create a negative 14? Negative 4, negative 10. So it's negative 4 and negative 10. Now, hopefully you've seen something like this before. If you have another way to think of it that makes sense, that's fine. This way, you'll make the fewest mistakes, though. Okay, now it's really easy. How do I turn factors into roots? Switch the signs, and what I'm really doing is setting each of these equal to 0, and then add the 10 and add the 4, and I get 4 and 10. So this graph crosses the x-axis at 4 and at 10. And we didn't need to graph it to figure that out. Okay, let's try a new one. So I want to know what are the roots. Similarly, if I wrote this, that means solve for x when y equals 0, which means find the roots. So I know last sign negative tells me they're different. Does it matter which one I put first? No, as long as the numbers match the signs, the order is not important. So I'll just put minus and plus. What else do I know? What does this tell me? Look at the chart. Last term negative, middle sign negative tells me that the bigger of the two factors is the negative. So I know that the big number is going to go on this side. So let's factor 48. 1 and 48. Now, I know that this one is going to be plus and this one's going to be minus. Does this work? No. So 2 and negative 24. Does that work? No. 3 and negative 16. Nope. 4 and negative 12. So 5 doesn't work. 6 and negative 8. Does that work? Nope. 7 and doesn't work. What does that mean? What happens when a number has no factors? If I said factor 47, you would say it's prime. So this quadratic is prime. Now, does that mean that it does not touch the x-axis? No. So there are a couple options. Maybe the graph misses the x-axis. Or maybe the graph touches the x-axis at numbers that aren't very nice, at decimals. And in fact, this is the case because I know that the y-intercept is negative 48. So it crosses the y-axis at negative 48, so it has to hit somewhere. But they must be irrational numbers. Okay, so sometimes they're not factorable, but that doesn't mean there aren't answers. We have to develop new ways to solve for them. Okay? What about this one? Let's change this to plus. So x squared plus 5x minus 6. What do I know about the signs? Different. So x minus and x plus. Factors of 6. 1 and 6, 2 and 3. Does one of those work? What about 2 and 3? Doesn't 2 and 3 make 5? Good. So I know that the big one goes here. So this list is minus and this list is plus. So if I tried -2 and +3, it's not going to work. Even though 2 plus 3 is 5, it's a -2 plus 3. So that one doesn't work. This is the one we're looking for. So it would be 1 and 6. So my factors would be, my roots would be 1 and -6. Are you guys comfortable with those? Okay, let's look at parts F and G. You should have created these quadratics. And one of the questions was, what happened to the middle term? It canceled. How come? There are two reasons why. First, the signs are different. And the numbers are the same size. So when the -3 and the +3 tried to fight it out, nobody won. They just killed each other and you get a 0. Okay? So whenever that happens, these are called conjugates. Whenever you have two identical factors that have different signs, they're called conjugates. And the nice thing about conjugates is that middle term always wipes itself out. When that happens, you create quadratics that are called, each one of them is a difference of squares. Now you need to remember those because I will use that word a lot. Difference of squares. It's called difference, obviously, because there's a subtraction, and it's two squares. This is x to the second minus 3 to the second. This one is x to the second minus 4 to the second. Difference of squares are the easiest quadratics to factor. So if I had x squared minus 121, what do I know about the signs? They're different. So x minus and x plus. Is 121 a perfect square? Yeah, 11 and 11. So my factors are x minus 11, x plus 11. My roots would be 11 and -11, and a lot of times we just get lazy and we say plus or minus 11. Okay, what about this? What are my factors going to be? X plus 6 and x plus 6. Are those conjugates? No. Is the middle term going to cancel? Will a 6 and a 6 turn into a 0? No, it has to be 6 and -6, so that's not right. So if I change one of these to a minus, would that work? Would the middle term cancel? Yes. Would they multiply to be 36? They would multiply to be -36. So what's the answer here? Well, let's try both negative. Will that give me a positive 36? Yes. Will the middle term cancel? No. So that didn't work either. So we tried 3 different times and it never worked. How are we going to factor that? You could do plus or minus, but then this would be a negative. Is this a difference of two squares? It's the sum of two squares. That subtraction is important. If it's a plus, even if they're both perfect squares, it will never factor. So this one is prime, and in this case, we have a parabola that misses the x-axis. So there are, in fact, no real numbers that satisfy that. So for today, the answer would be no solutions. Later on, we'll figure out a way to find some solutions. So when you're looking at something like this, it has to have perfect squares, and it has to have a subtraction. If it doesn't have a subtraction, it's not going to work. What about something a little bit more complicated? We have difference. It's a subtraction. Do we have perfect squares? What times itself is 16x squared? 4x. What times itself is 25y squared? So 4x minus 5y times 4x plus 5y. Now in this case, we can't find the roots because there are two variables, and that gets kind of complicated. But what if I didn't put the y's in the problem? How would you find the roots there? How did we get from here to here? I moved the number over so it equaled 0. So in this case, was that it? There we go. So I want to put this equal to 0, and I would add 5. 4x equals 5, and divide 4. We do the same thing on the other side, and you'd get negative plus or minus 5/4. Okay, for your assignment tonight, I would like you to finish the second page. You need to show your work, and you need to go all the way to the roots.